So I finally chased Jake out of the house. I had to let him stay a little bit. He brought coffee. So we sat down and, well, two old fat guys are discussing the woes of the world and coming up with solutions. You know, I finally politely, because the coffee's almost done, tell them to get the fuck out because I got stuff to do. And he says, okay. And I said, well, wait a minute, come on into the shop and I'll show you what I did because I'm so proud of myself. I had just finished, just before he got here, trimming out that little Type 21, this beast right here. So I put everything together in a bit of a rush because, you know, we both got things to do. So I put it together and then I put it into the test tank and then guess what? It floods out. Well, idiot me, while I was putting this thing together, notice what I'm doing here with a hot lamp and everything? I'm drying it out because I flooded the friggin' forward dry space here where the battery is and the magnetic switch. Well, fortunately, it's fresh water, and if you get to something quick enough and you blow out significant water, and then, and by blow out, I mean blow out the water, then you put it under heat for a couple hours and things will be fine. So this thing will survive. But I'm going to show you what I did real quick. It was as simple as this. When I buttoned up the battery, I slammed home the bulkhead, right? Nice. But one of the wires was hanging out and just grabbing the O-ring and became a leak path. But it was underneath and I didn't bother to roll this thing to make sure that the O-ring was entirely seated. So I got rushed and screwed that up. And when I put it in the water, Jake is going, oh, gee, it's floating on the surface real nice. Yeah. Then I vented the tank and it dove. And I mean dove. Bow first. Well, that told me something was wrong. I grabbed it and, of course, extracted the cylinder and went through all the aforementioned bullshit to dry things out. So it's about ready to go. But I'm going to give it another hour under the heat lamp. So having completely screwed up the 21, let's go and see what horrors can be committed to this poor, innocent, unsuspecting 196 scale phase 4 or phase 5, I forget, albacore. So we're going to make this thing ready and see if we can't flood its cylinder while I'm doing the final trim. So that's my story, and I'm sticking to it. What a clusterfuck. I got rushed. Didn't take my own advice. You know, take it nice and slow and check twice and all that crap. I just threw it together and suffered the consequences. So, on to this poor guy right here. So, let's see what we can do to that. All right, after a day and a half of messing around, problems with linkages, I had to re-engineer the dorsal rudder linkage here. So, one, it wouldn't interfere with the very tight confines within the hull, and two, I had to get the distance between the magnets, the upper linkage arm, which is in the wet, and the servo output arm here. I had to get that worked out. Boy, that took forever. And then I had a problem with the antenna. I was jamming up in there, so I replaced that. And further complications arose when I was working out the hose which leads here. You can just see it there, the manifold, which leads up into the sail where the snorkel is. And this hose then connects to the induction side of the cylinder. In fact, I'm running that hose in now. Notice how I'm fair leading it through a strain relief device right there. That's to keep the hose out of the road. So putting the hull together is now a relatively simple manner. I slide this guy on, and of course that thing flops over. There we go. And then, boom, you got the hull. Notice how the dorsal rudder just started to behave right away. That's when that magnet made up to its counterpart at the ass end of the cylinder. So, we're ready to put this in the water. And like I say, after a day and a half of fucking around with moving weight, fixed ballast weight, and adding and subtracting foam, I finally got this where it's operating effectively in surfaced and submerged trim. So there we are. This guy's ready to get wet. All right, so let's turn things on. First thing, of course, the transmitter, then the model. Hear all that going on back there? Okay, things just flopped into position. Now, demonstrating how that dorsal works. See, when I roll the model, that dorsal rudder moves as a consequence of my roll. That's automatic. There's an angle keeper in there which monitors the roll axis, and that's what you see right there. And of course we have another angle keeper oriented to be sensitive to pitch, and you can see what happens there just by moving the model. I'm not touching the transmitter. Okay. Roll this thing back where it should be. And I'm going to operate things from the transmitter now. Propulsion. This is rudder, believe it or not. And this is pitch, the equivalent of stern planes. That's the virtue of an X-tail, is you get about a 30 to 40% increase over a cruciform arrangement with the X-tail. Kind of a play on the old Beechcraft V-tail, but in this case we have an extra set of surfaces. Okay, and let's see, we tested all that. Let's see how the ballast system works. Good. All right, well, let's put this guy in the water. Center this thing. Now, of course, we're in surface trim right now. And we got the water line pretty much where it should be. Now I'm going to go ahead and vent the tank. As the ballast tank fills with water, I'm going to help this out a little bit. It caught a bubble. I'm going to back down a little bit. There we are. Still got a bubble in there somewhere. It's still light in the ass end. So I'm going to take out a little bit of foam. I already took a little piece out, but we're still a little light aft. Oh, we'll address that. Okay, other than that, I'm pretty happy. Again, notice the dorsal rudder. See that? Pretty slick. And since the boat has a definite down angle because it's too light in the stern, what I'm going to do is just take out a little bit of foam. But you'll notice how the X-tail responds to angular displacement. I don't know if you can see it too well, but let's try this. See that? That's what keeps you on a near zero bubble angle. All right, I'm going to go ahead and do a blow here. Now listen. And slowly the model comes up with the ballast tank dry now. We've taken out all that weight, which accounted for the weight of the water displaced on all these above waterline surfaces. All right, so that's what just happened there. And I can see I got a little bit of a list to starboard, so I'm going to take out some foam back aft on the port side, and it'll do two things. It'll help correct that slight list we got, and we'll lose some flotation back here, which will bring that ass end down a little bit. So once again, when we get back into submerged trim, it'll be on an even keel, not with that nose down attitude. So, okay, that's a pretty good run. You can see how the dorsal rudder is already accounted for that slight list. Now look what happens when I put it back where it should be. Boom! Automatically, just like that. Now I can also trim that from the transmitter. See what I'm doing there? But I want that centered. And once this boat is back on a correct roll angle, which is 0, you notice the dorsal rudder goes back to neutral. All right. Well, that was a pretty good run. Let's we're going to take it back to the bench. I'm going to remove a little bit of foam there, as I indicated, and test it again. And I'll do that maybe 2 more times before I button this up for its trip to cabin fever. Everything's working fine. Okay. We turn off the system, like so. We affirmed it's off by twiddling the knobs here. Nothing, good. And then we turn off the transmitter. And remove the single securing screw, like so. And remove the upper hull, which is a relatively simple matter. Now we're still made up here, as you can see. So pull that out, put this aside, and I'm going to blow this down to make sure we didn't get any water. Going to make sure we didn't get any water in the cylinder. Turn it upside down. We'll give it a good look-see. Everything's fine. All right. So we got to remove a little bit of foam. I'm going to go after that guy there, and then we'll test it again. The dry spaces are dry. Mechanically, the model's in good shape. I've got the dorsal rudder dialed in, and we're not far away from being ready for cabin fever. It's nice when things work out. Well, there it is. 196 ALBACORE phase 4, maybe phase 5, not sure which. A research submarine, not a combatant, basically a very, very large scale model of proposed hull form and various control surfaces and propulsion arrangements. It was a test submarine. This model kit originated with Scott Terry out of Australia, an excellent craftsman. His strong suit was building masters, tools, and fiberglass hulls. He shared his work with me, and I shared my cylinders with him, and we employed that barter system for several projects that we worked on and enjoyed our hobby, and basically worked to each other's strengths. Cancer killed him about a year ago, I think. Too bad. I don't think he ever finished his albacore. But that's the way the cookie crumbles. The interesting feature is that the escape hatch, the after escape hatch, sits proud on the deck, and it's not streamlined like the forward escape trunk. Here. Reason for that is they didn't have room in the engineering spaces to drop the trunk to do that, and they wanted the streamlining up front. That was vital because they were doing studies with various hydrophones in a sonar array, and they didn't want a big noise source, which would be presented by an external hatch, flow noise, that sort of thing. Here you can see the mast array. So there it is. That's the beast. Over the years, I had collected from him not only this albacore, but 196 models of the Russian equivalent, which was the Beluga, a Romeo class, and a Zulu class. And I think something else. I can't quite recall what its NATO name was. But he was big into exotic submarines, of which, of course, the albacore certainly qualifies as exotic. Quite a nice-looking boat. Here's the egg beater. You see these indentations in the side. They scribe lines to note water breaks. They were so scared of sternplane casualties because this thing did not have an exceptionally deep test depth. So they tried several measures to apply the brakes if they ever got into a down angle at speed. And these petals would actually open up into the flow and retard their descent. They even put a B-47 parachute atop the sail, and they deployed it a few times. That must have been a shit-inducing experience and control. I think this thing was manned by fucking pirates. I mean, these guys had to be nuts. But they got it done. And the progeny of this thing, among many, was the skipjack. The long-suffering Thresher class boat with the same type of propulsion, not electric, but steam-driven. What the hell was the name of that thing? Oh, the Jack. Yes. Guys were always bitching about shaft seal leaks. Imagine trying to keep the water out of two concentrically running shafts. Ugh. So, but a historically important submarine. And the United States Navy would not be doing an X-tail until Rickover was well into his grave, because that conservative engineer would not tolerate an X-tail. His principle, and I abide by it, and old school guys still do, if you can't put a man in the loop to fix what went wrong mechanically, don't put it in there. And X-tails demand a bit of a computer, be it analog or digital. It needs some computational ability to mix your inputs for yaw and pitch. And you just can't do that with a piston pilot valve back in maneuvering. That is kind of overreach for any guy trying to operate those things manually. They have to be mixed together by a mechanical analog or by a digital computer. And the story goes that Rickover told Bew Ships at the time, nope, not on my watch. But that was decades ago. Here we are now. Next stop, cabin fever.